great to hear the historical context of software-based art from a curatorial perspective. Now we'll hear the historical context from a technical perspective. Our next speaker is Mark Hellar. Mark is a leading technology consultant for cultural institutions throughout the San Francisco Bay Area and beyond, and owner of Hellar Studios, LLC. Mark specializes in creative yet practical digital media and web-based solutions for multimedia artists and the institutions that support their work, with an emphasis on developing systems and best practices for archiving, documentation, and exhibition. Before opening Hellar Studios, LLC in 2009, Mark worked as a systems architect at the Tides Foundation, the academic technology manager at the San Francisco Art Institute, and as a digital media specialist at Bay Area Video Coalition. Mark is currently working on new media conservation initiatives at SF MoMA, including the conservation and care of their software-based artworks. Mark will be speaking about the history of technology underlying the evolution of software-based art. Please join me in welcoming Mark Hellar.
Hi, everyone. Can you hear me? Thanks, Christiana, and thanks all for coming. It's a pleasure to be here. And so, yeah, I have a long title on a long topic, the history of technology underlying the evolution of software-based art. So I'm going to add in a nutshell to that. Now, give me 1 second. So let's talk about early inputs and outputs. Early computers, sorry. So early computers such as the UNIVAC Console 1 and the Zeus C3 terminal didn't really have much for output, blinking lights, and this really didn't lend itself to visual art so much. For input, you had to tell the computer what to do. You had to write a program. And so you'd write that program in the early days in something called assembly language, which was a low-level computer-specific machine language. So here we have a early assembly language program for the DEC PDP, Digital Equipment Corporation PDP-8. And what it did was write Hello World. And you see, it's quite a long program. These are comments. And these are machine-specific commands that would set it up. The characters had numeric codes. And so it's quite a program. And the way you would write this program is you'd work it out on a coding sheet in pen and paper, then transcribe that on a key punch to punch codes. You'd feed those punch cards into a computer, and it would translate that assembly language into machine code. Machine code is a language a computer understands. It's not very readable by people. And everything worked. You didn't have an error or anything like that. You might get some nice output on a printer. And so that was early output. Output improved. Here we have the Zeus Graphomat Z64, which was a flatbed drawing machine invented by Conrad Zuse. It was originally intended to be used for the production of maps for land registration purposes, but it also became the canvas for early printed works by George Neise and Frieder Nake. Here's another early printed work, Random War by George Surrey, 1966. That was created on an IBM 7094 mainframe, a Calcop drum plotter, Model 565, and punch cards. So this was kind of the early process for generating these works. Input improved, and we have Admiral Grace Hopper to thank for that. She was the inventor of the first compiler. And so Hopper assigned call names to a collection of programming routines stored on magnetic tape. One could call these desired routines, and the computer would find them on the tape, bring them over, and execute it. And this was the first compiler. So here's Hello World in a higher level language, COBOL. And so you would have sort of these sections. This is the identification division. And so in that area, we give the program a name, hello. And then down here in the main section, we have a routine display, and we can actually type hello world. So computer languages are becoming, more human readable, and programming is becoming more productive. So here's a hierarchy of languages. We have the hardware. We have machine language, which is what the hardware understands. Assembly kind of abstracts out. It gives short names to computer-specific instructions. Yet it's quite intensive to write still, but it's very efficient. A higher level language refers to the higher level of abstraction from machine language, making the process of developing a program simpler and more understandable. So we have higher level languages like COBOL, C, and then those even get abstracted to higher languages such as visual languages we'll talk about in the subsequent slides. Output evolved as well, and so we have some early CRT or monitors. These are vector displays, and they display images which are composed of drawn lines. So artists like John Whitney and Lillian Schwartz would write programs, develop programs, and capture the resulting images on film. And so these would result in some early pioneering examples of computer-mediated works of the moving image. Another great pioneer of the computer science was Dennis Ritchie. And Dennis Ritchie invented the C programming language, the operating system Unix. We could go on about what these are and their contributions. They're responsible for the iOS on your phone, Android, Windows, all these things. It's very important. And so C was a high-level language, a very readable language that enabled programmers to write structured programs that were close to the speed of assembler. They were extremely fast. And they were also portable and would compile on different machines. Assembly language and machine language were specific to the computer. Higher level languages like C, you could write in C and then compile it on multiple different types of computers. Here's Hello World in C, the first version of C. So here we have main, that's the main program. Here's a command, it says put string. We put a string of characters Hello World. And then we return 0 to end the program. So it's getting abstracted and more readable, a lot more so than from early assembly. Okay, now we jump to the Commodore 64 and computers in the home, 1982. Input and output has changed here as well. Commodore 64 gives composite video output. You can plug this in your television. And it gives you a nice command line. You can just type commands telling the computer what to do. It came with a high-level language called BASIC, and here's a one-line program, and what this does is it prints a character string of either 2005 or 2006. Character strings would generate a graphic image, so 2005 would be a character like this, 2006 would be a character like that. It would go to 10 and loop over and over. So you have a one-line program generating some very interesting graphics. So programming is no longer the realms of these professional programmers in white coats studying assembly language all day. You can learn to program, and so these are some books that were sort of typical of the 80s, telling you how to create graphics on the Commodore 64. I actually love this cover over here. This is for the Atari computer. And it's kind of like, all right, learn basic programming. You can become master of not only the computer of the universe, you can be Admiral Grace Hopper as well. Okay, so jumping ahead to 1987, the Macintosh. And the Macintosh, Apple created HyperCard. HyperCard was an early system of hypermedia that consisted of a series of cards that would contain graphics, audio, text, later video. And you could link the cards together. So you could have a stack of cards on a subject, they're interlinked, and they have media on them. What was cool about HyperCard is also came with a language called HyperTalk. And so you could write little scripts, little programs, attach them to buttons, attach them to images, things like that. And you could click on them. This gave the media interactivity. You could open up programs, play sounds, etc. So early work that was built in HyperCard was Lynn Hirschman Leeson's Deep Contact. That was made in 1984. And it had a touchscreen interface, and the software interface was built in HyperCard. There were buttons, and the buttons had scripts attached to them that would control, they would call chapters on a laser disc via a serial cable. So here we have a very interactive, early interactive video installation controlled by software. A little later, we have Max, which has a very interesting history. I could talk about Max probably all day, but I'll just say that it was developed by Miller S. Puckett at IRCAM, the Institute for Research and Coordination Acoustic in France. And it was a visual programming language where blocks of functionality were patched together to build a program. So you had all these sort of functions, but you would see them as visual blocks, and you patch the inputs and outputs to create this program. Now I'm going to show a clip, a sound please, of Letitia Tsunami, the lady's glove, and she built a glove with various sensors as input. It would control it would give that input to a Max program, and the output would control hardware synthesizers and audio samplers. So, there's sound. Sorry, it's a little quiet, but okay, there we go. Oh, okay. Oh, that was good timing. Okay, here's another important work, and this was Julia Shears' Predictive Engineering 2, 1998. And Julia Shears' work explores issues related to electronic security and surveillance. This work was commissioned by 1997 by SF MoMA for the opening of their new building. Predictive Engineering 2 was controlled by a Max program that would interface with hardware and switch live camera feeds and stage footage on DVD to external monitors. It could be triggered by laser sensors in the museum and would also control the playback of audio samples and graphic overlays. Really wonderful piece. Okay, so now I'm going to move forward to the era of the multimedia CD-ROM. We had CD-ROMs, optical discs. They were cheap, they had a lot of storage, and they were reproducible. So here you have multimedia, and so Director was a large player in the multimedia scene, Macromedia Director. And you sort of had this analogy of a stage. You would put things here, buttons, graphics, videos, a timeline to animate that. They had a cast of actors. Those would be objects you would put in there. Now, much like HyperCard and HyperTalk, Director also had a language lingo. And so you could attach programs to make these pieces of media interactive. And so it's important to note that the inventor of lingo was John Henry Thompson, who studied art at the New York Student Art League and the Boston Museum School, and then went on to earn his degree in computer science and visual studies at MIT. And he became the lead technology scientist at Macromedia Creative Director. So we're going to be looking at Sebra and Vercé's Untitled Film 2 this afternoon. That was created in Director, and so I'm looking forward to that. Okay, so we're in the era of the CD-ROM, and then we get to the early web. This is Holger Fries' Unendlich Fast. I hope I said that right. I was practicing on Jonah. So this is an early sort of piece of net art, and imagine this is your browser, and I'm scrolling there, and I'm scrolling down here, and I hope I find this thing, and then, there it is, and you get this interesting image. Early web pages are created in HTML hypertext markup language. It's a content formatting language. It's not really interactive. And here I have a bunch of line breaks, hundreds of them. And down here I have a width of 200,000%. And then embedded in the code I have an image. So Holger Fries is being very inventive to create interactivity where there was not on the early web. So that sort of leads to the battle of the interactive language for the web. I'm going to start with Java. Java was originally created by Sun Microsystems for interactive television, set-top boxes and things like that. But the web was becoming interesting, so Java changed focus. And they added a feature called applets, for programs that you could run in a web page via the Java plugin. So some important pieces in Java were Mark Napier's Net Flag, which is a work of internet art created in 2002 by Mark Napier, along with Unfolding Object by John F. Simon Jr., which was commissioned by the Solomon R. Guggenheim Museum in New York City, and it was among some of the earliest works of internet art to enter the permanent collection of a major museum. John F. Simon Jr., Unfolding Object, where he describes his work as an endless book that rewrites itself and whose use dictates its content. So I wish I could show these pieces in detail. I don't have time, but you would interact with them. Net Flag, you would design a flag. Very important pieces of early internet art. Okay, so Sun wants Java to be the interactive language of the web. Netscape, creator of Netscape Navigator, they jump into the fold as well. This is JavaScript, 1995 to the present. JavaScript was a little less robust. You could have buttons that would calculate totals and sums and things like that. You could attach scripts to buttons. So here I attached a script to this button that gives a message, welcome to TechFocus 3. Important things to note about JavaScript. It was written in 10 days by a man named Brendan Ike at Netscape. It was named JavaScript due to the popularity of Java at the time. These are different languages. That was a marketing move. Java code needs to be compiled while JavaScript code is executed by the browser. And now, Macromedia had made Director. Director was for Multimedia CD-ROM. They started to have internet export as well, but it really evolved into Flash, an action script. So Flash, I'm sure you've seen Flash websites. Flash had a stage, a timeline as well, properties that you could give it, library of scripts and animations and drawing tools. And it also had a language called ActionScript. And so here's a little snippet of code where we had 3 buttons, and on click, call a function. These functions would show images, etc., creating interactivity. A great piece in Flash, an early piece that's still on the web today, TheyRule.net by Josh On, which was a visualization of corporations, people associated with them, and banks that funded them. And you could create maps and navigate it. So it was also a great piece of early data visualization, quite complex. Over at MIT Media Lab, the director John Maeda is working with Java, but he makes a new language built in Java called Design by Numbers. And here's an experiment where he wants to create a language that's accessible, has a vocabulary of art and design. So he creates functions like paper. This is the paper. You create a pen, and with that you draw a line. There were 2 students at MIT Media Lab, Casey Reus and Ben Fry. Under the guidance of John Maeda, they created the processing language. You're going to learn about this in the practical session tomorrow. This extended the ideas of Design by Numbers by a vast fold. And here's a language, a programming language for visual artists and designers, or engineers who want to learn about visual arts and design, new vocabulary, a new program. Processing's amazing. It sort of kicked off this creative coding era where people could be creative with code. And it was a language, but also a philosophy. Here's an image of Casey Reus, one of his early algorithmic works, Articulate built-in processing. And so the processing philosophy also, is a language and a philosophy. It had sister projects. This is the Arduino. It started off in 2005. Arduino took the ideas of the processing language and wanted to make a language that was accessible for hardware engineering, for artists and designers. You could add interactivity to your work, sensors, motors as output, things of this nature. And so I've been teaching both of these platforms to art students in San Francisco, and they always ask, what can we do? And so I bring up things like Marcus Kiser, solar sintered bowl. And Marcus Kiser used Arduino. He used processing and made some machinery. And he made this 3D printer, this solar-powered 3D printer that uses the sun to focus the rays of a Fresnel lens on sand, and then feeds 3D geometry, 3D objects, into processing, controls the actuators with the Arduino. And so he created this solar sintered bowl, which was collected by the MoMA's A&D collection in 2011. Paula Antonelli, senior curator in the department Department of A&D at MoMA stated the two most important introductions for art in the past 20 years have been the Arduino and processing. So these are very important languages and movements. Okay, so we saw the early web, and now we're going to move to the modern web, 2005 to present. HTML got an upgrade. JavaScript evolved, and CSS, cascading style sheets, also work. HTML, you would structure your content. CSS, you would give it a style. And JavaScript, you would make this interactive. So HTML gave a canvas element or canvas tag, and you could draw to this using JavaScript. So this is kind of like your stage and Flash, your director. But now it's not owned by any company or corporation. It's just part of the web standards. Spice up your JavaScript a little more. You could add animation, interactivity, things of that nature. Other elements were scalable vector graphics. We only have rasters. So scalable vector graphics are quite nice because they scale. This won't work. Let's see. Will this work? Okay, so we also had real-time data components. These are called WebSockets. They're part of the HTML standard. So I'm just going to say hi here. This is going to send message to a server at websocket.org, and I receive it immediately and get instantaneous feedback. So I get real-time data, good for data visualizations. And so these are just a few of the components of the modern web. There's many more. But these are some of the building blocks that you're going to see in in the drawing interface for Jörg Lenny's Victor, which you're going to hear a great case study about this afternoon from Martina Heidvogel. And so you could now create complex applications using modern web technology within the browser and not dependent on a company such as Sun Microsystems or Adobe. And so in April 29th, 2010, Steve Jobs published this letter called Thoughts on Flash. He's like, yeah, Flash is not going to be allowed on iOS devices. He cited a desire to avoid a third-party layer of software coming between the platform and the developer. And this sort of shook the death rattle for Flash. Firefox Browser just announced they'll no longer be announcing Flash, and it's expected that other browsers will be following suit. Sun Microsystems was acquired by the Oracle Corporation, and business priorities shift. Applets were useful, but not as useful as other parts of Java. So applets are actually really hard to run in the browser these days as well. Okay, I want to talk about networked version control. So network version control, people are sharing their code on the web, processing, people are adding code, adding libraries, sharing their code. And so this is Raphael Lozano Hemmer, the artist. It's his GitHub page. And GitHub's a place on the internet where you share code and you collaborate on code and things like that. Oh, and so I just want to show this clip from the documentary Clouds that sort of shows some of these artists talking about the effect of the network on creativity.
In general, everyone in this community is used to sharing in some way.
Humans are connecting from across the planet and creating something larger.
I think you can equate building a tool and building a language.
It's almost like people across the planet are dreaming together.
So that's a great documentary. It's you download a piece of software and you hear all these artists and technologists talking about their ideas, and it's software, so you navigate programs and things like that. It's like $10 and you download the software. It's really great. It just came out months ago, but one of the topics is network creativity. So Level of Confidence is an art project to commemorate the mass kidnappings of 43 students from Zanipa Normalista School in Iguala Guerrero, Mexico. The project consists of a face recognition camera that's been trained to tirelessly look for the faces of disappeared students. As you stand in front of the camera, the system uses algorithms to find which students' facial features look most like yours and gives a level of confidence on how accurate that is. The source code of this and the the actual artwork is available to download online, so it can be exhibited at any university, cultural center, gallery, or museum. He gives PDF physical installation guidelines, and he also gives the source code. He states that you can modify it yourself, train the faces on other disappeared people. You know, you can take the code and change it. Now, he built this in a library called OpenFrameworks, and it has plugins. So he actually gave back the face recognition code from his piece to the community. And so this is kind of a shift where like people are sharing, artists are sharing. This is OpenFrameworks. It's kind of built out of the ideas of processing. It's built in C++. It's really fast. Doesn't run on the internet. But level of confidence built in this huge community, and Raphael Hammer is part of that community giving back. This was initiated by Zachary Lieberman in 2005. Okay, I'm almost done. So Java is, processing's in Java, processing evolving. Lauren McCarthy, faculty at ITP and NYU, was a processing fellow. And so she wanted to continue the ideas. P5.js is a JavaScript library that starts the original goal of processing to make coding accessible for artists and designers. And so she's porting this. She does say it's not a port, it's a new interpretation. And so she's porting this and giving a guide, and she's taking all the functions and processing and porting to JavaScript. So this is kind of how the community is evolving and sort of conserving themselves. Okay, I'm out of time, so I want to say thank you to all the artists and programmers who made this possible. Jill Starrett, Director of Collections at Conservation at SMOMA, Martina Heidvogel, Media Arts Conservator at SMOMA, members of Team Media A&D, Dina Engel, Joanna Phillips, Brian Castriota, TechFocus 3 Planning Committee, all of you, thank you very much, and you can get a hold of me and questions. No questions?
I have a question.
Oh, yes.
Of all the different sort of language and technologies you just presented, sorry.
Yeah.
Of the different languages and technologies you just presented, are there any that you would characterize as particularly high risk because they're either no longer supported, likely to be no longer supported, or proprietary?
Well, I mean, Java and Flash, I think right now, because they're not going to run in the browser at the end of the year. If you have the source code, when the Canvas element first came out, people were creating tools to migrate Flash to the Canvas. So there's strategies there, but that's only if you have the source code. Flash is compiled. Java's quite readable. So you have the source code for that. You look at John F. Simon Jr., every icon, there's a Java applet that doesn't run the web browser, but he ported to JavaScript. And they're a little different, but you have the source code, you can read it. Max is quite interesting. I love Max, I own a copy. Those objects though, it's written in C and C++. Those objects are compiled and you don't get the source code of it. It's proprietary. And Max is a little company. It had a long history. It's a little company in San Francisco. And they're friends of mine, and they actually got priced out of their office. They're all working distributed now. So Max I got a little worried about. You like to watch this. JavaScript's open. It's interpreted. You always get the source code. So I'm a little more comfortable with that. So that answers the question. Sure. Okay. Jörg. That's true. When we talk about, so JavaScript, each browser has a JavaScript rendering engine. Chrome has V8, which I think is fairly proprietary.
Yeah, but also just the HTML5 technologies that you're using, they are in constant flux.
They're changing and getting deprecated and things like that.
Or also just, there's like new glitches with every new version of Chrome. So you almost need to like conserve the version of Chrome that runs your art piece.
This is true. Things are evolving so fast. ever more now so than ever, you're getting a new feature, a new technology, things are getting deprecated. So you can say emulate it. Well, you're going to talk about emulation of the web, or you're constantly migrating. I don't want to sound dire, and we're talking about NetArt here, but that's true. Browsers are getting new features and saying, oh, we don't need these anymore, yearly. Soon might be monthly or weekly. Thanks.